Good day and welcome back. This is our second installment dealing with curl and divergence. And sad to say, this is actually the final video covering the Calculus 3 material. In this video, we'll introduce the concept of divergence of a vector field, go through some computations, and mention a physical interpretation. For a three-dimensional vector field, in this case f equals pqr, we define the divergence of f to be the quantity del dotted with f. So recall from our previous video, we had the curl of a vector field was del crossed with f. Divergence comes from taking the dot product of the two. So in terms of computing this quantity, we would have the vector del, so partial x, partial y, partial z, which remember by itself is rather meaningless, but when combined with a vector, like say PQR, now we have something we can work with. And recall that for a dot product, you multiply together the corresponding entries and you sum them up. So P sub x plus Q sub y plus R sub z. So let's go ahead and work through a computation. For the vector field f, which is x, y, z, 0 minus x squared y, we should be able to very quickly and very efficiently calculate its divergence. The divergence would be the partial derivative with respect to x of the first entry, plus the partial with respect to y of the second entry, plus the partial with respect to z of the third entry. As the second two partials are both going to be 0, we end up with the divergence simply being the quantity yz. And at this point I would like to observe, similar to calculating the curl of a vector field, this is not something which is difficult computationally. As long as we have functions we can differentiate, we can quickly and efficiently determine what is this quantity that represents the divergence. So the question naturally arises, why would one be interested in this? Is there some physical interpretation related to the vector field? And it turns out there's a similar interpretation to what we saw for the curl of a vector field. If f is once again representing the velocity vector field of some fluid flow, then the divergence of the vector field at a point will measure, in a sense, kind of the mass of the fluid flowing away or flowing through the point with respect to unit volume. And if it's okay to steal the word divergence itself, we could say that in a sense we're measuring kind of the tendency of the fluid to flow away from or diverge from a point. And I will throw out the disclaimer, this is not something we are going to explore in this class, but as an application in other classes it may come up, and it's also a very important idea when it comes to something called the divergence theorem, which you may encounter in future courses. For now, I would like to finish up our discussion on curl and divergence with one more example. We have a vector field with 3 entries, and I just want to think purely from a computational perspective. Can you calculate the curl? Can you calculate the divergence? And I would ask that you pause the video, take, once again, 2-3 minutes, and see if you can calculate out these two quantities. And hopefully you've paused the video for a few minutes and you've already worked through these computations. So I have a starting point. The divergence of f is del dotted with f, so the partial with respect to x of e to the x, plus the partial with respect to y of that middle entry. And using the chain rule, we would have e to the xy times the partial of xy with respect to y, and then the partial with respect to z of that third entry. So using the chain rule, the derivative of the outside evaluated at the inside, multiplied by the derivative of the inside with respect to z, which is xy. And I would leave it exactly in this form. For the curl of the vector field, remember that's del crossed with f, which gives us a 3×3 determinant to compute. So for the first entry, we cover up the I column, the I row, and we calculate the determinant of this remaining 2 by 2. Partial with respect to y of exz minus partial with respect to z of exy. So that would be e to the xyz multiplied by xz minus 0. Then in the middle entry, we start off with that minus sign. We cover up the row and the column of that j entry. So we have the partial with respect to x of e raised to the xyz, subtracting away the partial with respect to z of e to the x. So in this case, that would give us e to the xyz times yz minus 0. And then similarly for the k entry, we would have e to the xy times y minus 0. And this finishes up our discussion of curl and divergence of a vector field. When it comes time to exams and homework, the types of things we should be able to do are the computations, like we've seen here, and additionally, remember this idea of how we can use the curl of a three-dimensional vector field to determine if it is conservative. So with that being said, take care.